Good afternoon. We're back in session. We're all fill-ups here, okay? So I'm filling up. So, but I think we know what we're talking about. I hope. I'm not going to repeat the introduction of Gal Luft. He's just been introduced, but I'm going to introduce Gerald Fletcher. He's a professor of energy, environment, and resource economics at West Virginia University and director of the U.S. Advanced Coal Technology Consortium of the U.S. China Clean Energy Research Center. He also serves as director of the National Resource Analysis Center, director of U.S. China Energy Center, faculty research associate with the Regional Research Institute, and adjunct professor of economics. He has testified before the U.S. China Economic and Security Review Commission and served as an Institute Fellow with the NETL Institute of Advanced Energy Solution. The result of the collaboration between the U.S. Department of Energy, National Energy Technology Laboratory, and selected universities that focused on the research related to fossil fuel utilization and carbon management. He has published widely in a variety of disciplinary and interdisciplinary journals and books. Much of his current research relates to the management option and economic implication of the environmental consequences of coal utilization, carbon management, and public policies that affect societal decisions related to energy and natural environments. He received his PhD in agricultural economics and MA in economics from the University of California, Davis, and his bachelor degree in mathematics from the University of Wyoming. The session this afternoon will focus more on oil and fuels and largely on solutions that could exist in both countries. I think it's quite interesting and surprisingly how much is happening that most people are not aware. Perhaps who would like to start? Maybe Gal will start and we'll talk a little bit about some of the other economics of interesting productions of fuels from that. So with Gerald. So I'll sit down and you don't need to see me here.
Go ahead.
Okay. Can you hear me? Yeah. My focus on this in this conversation will be on something that I think perhaps the most important opportunity when it comes to fuels is something, an initiative that we launched with the Chinese maybe 3 years ago, from the understanding that both countries have unique capabilities in fuels that are almost cousins in the family of alcohol fuels. See, the United States has a very well-established ethanol program. We have a lot of experience in this fuel. A lot of people don't like methanol. A lot of people do like it. We leave it aside. But the point is that we have a robust industry. And China has a robust industry of fuel that is quite similar in its characteristics, and it's called methanol. Okay, so methanol and ethanol are both alcohol fuels. And they are different in the sense that ethanol is largely manufactured from grains and from agricultural product, and methanol is produced from practically anything that has carbon, whether it is coal or natural gas or biomass. There is even a plant that produces methanol from CO2 in Iceland. So we figured out that because those two alcohols are compatible and they could both be blended into the gasoline supply, that there is some synergy. And we decided to establish something called the Joint Alcohol Fuel Alliance, which brings together ethanol interest and methanol interest and automobile makers and government officials and so forth. So this is one of the proposals is to use the knowledge and experience that both countries have accumulated over the years. And there was no real interest in the United States in methanol because it was not, because methanol in the United States is made from and most of the methanol in the world is made from natural gas. But now when we have so much natural gas, so cheap, it's now under $2 a gallon. And we barely utilize it. We only 1% of our natural gas supply is used as automotive fuel. So we have incredible capacity to utilize more of our natural gas in the transportation sector by turning it into methanol and blending it into the fuel supply. Now, China has already been doing it for many years, since the 1980s, and it has tested methanol in millions of vehicles, primarily on the low blends, which is M15, 15% methanol, 85% gasoline. It started as an initiative in the coal provinces because in China, unlike the rest of the world, methanol is made from coal. And it was something that started in the coal provinces and gradually moved to other provinces. And today there are at least a dozen provinces that are actually blending methanol in various blends. And there are provincial standards that support it. So in other words, in those provinces you can use M15, M45, M85, M100, depending on the province. There's an incredible amount of experience in blending, in manufacturing, in handling, in safety procedures. And we thought that it would be a smart idea to tap into all of this vast experience and see what the Chinese have done and to see what we can import to the United States and share with them our experiences. And by the way, also bring in Brazil, which is another alcohol fuel country with a lot of experience, although they make their ethanol from sugarcane and we make it from corn, but essentially it's the same product. So we initially called it the ABC Alliance, America, Brazil, China. Then other countries came along and said, we are also interested. Israel being one of them, we're also interested in. So then we turned it into JAFA, Joint Alcohol Fuel Alliance. And we really use this as a platform in which we can share, for example, if there are new standards or pilot reports that are, we would translate it from Chinese to English, and so we can all get access to the same information. And I think that this is an opportunity because, as I said before, the auto manufacturers, including the American ones, are not in a position to give up on the Chinese market. In other words, if China tomorrow decides on a national standard for methanol and says that it is okay to use M15 in any vehicle, which is de facto what's happening in several standards today. There are many places in China where you can go into any gas station, fill a car with M15, but the car is not warranted to run on M15. People are using it because the fuel is cheaper. So they like to buy the M15, but the warranty doesn't cover for it. But very easily, China could declare that they're national standard for M15, and at that point, the automakers, if they want to sell cars in China, will have to certify their cars to run on M15. Okay, if that happens, then it effectively means that cars all over the world will be certified to run on M15, because it's hard for me to see how GM will make cars to the Chinese market from where they're certified to run on M15 and not do the same in all of its other markets. Although they could do it, and I can tell you that it's interesting because take the position on ethanol, for example. So in the United States, the oil companies are fighting hard against the E15 standard. They don't even like E10, but E15 is really too much for them to bear. And they're publishing all kind of studies about the damage to the engine and so forth. And then you go to Thailand, you go to Bangkok, and the same oil companies that are fighting ethanol in the United States are promoting E20 in Bangkok gas stations. I'm talking about Exxon and Shell. So where you sit is where you stand, or type of thing. But we know today that the notion that it has negative impact on the engine is pretty bogus, because the amount of methanol has been blended. And we have enough experience to show, to monitor that it's not really detrimental to the engines. In China recently, the interest in methanol has expanded into two new sectors. One is the marine sector, because there's a big problem of water pollution in the rivers. The big rivers, like the Yangtze River, the Pearl River, you have thousands of boats going up and down, and they run on diesel, and they leak. And that creates water pollution in those rivers. Methanol is very interesting here because it biodegrades. If it leaks into the water, no problem. There's no lasting environmental damage. So now the Chinese are interested in implementing this in the marine sector. Second thing that makes methanol interesting for the Chinese, as well as the United States, could be, is the fact that methanol contains no sulfur. So if you want to reduce your sulfur emission, it's a very good way to do it. The third area where I think it is very interesting is the heavy-duty sector. In fact, last June we had a mini conference on methanol use in heavy-duty vehicles. We did it in Beijing. And in China, 40% of the fuel is diesel. So if you find a solution to the heavy-duty, you can reduce pollution quite significantly. Now, the interesting thing about this is that we learned something that is quite counterintuitive, that coal-based methanol, in other words, fuel made out of coal, when it comes to pollution, almost in every criteria, is much better than diesel, including, and we actually have in our reports the results from the University of Tianjin, and they show the comparison between direct diesel methanol fuels and major reduction in CO, nice reduction in NOxes, and the most important one is 50% reduction in soot. And so you can see that contrary to what people think, coal-driven fuels like methanol or dimethyl ether offer significant air quality benefits as compared to petroleum-based fuels. When it comes to CO2, it's a different story, because you got to look at the entire fuel cycle. Okay, but if you only look at that's why when I made the comment before about are you focused on harmful pollution or CO2, that's where those decisions need to be made. Do I go for a fuel that reduces my petroleum use and also reduces air pollution, but may not be a good solution for carbon emissions? That's a kind of decision that I think we'll have to see where the Chinese government will go, because if they are concerned about pollution and they are concerned about oil imports and they want to be more self-sufficient, then there's more of a reason to increase the use of coal in the transportation sector rather than decrease it. So it is yet to be seen. I don't think that the Chinese central government has made a judgment on this. It could go either way. The provinces have said their word. The provinces are there. And in China, provinces have a lot of power. They can enact their own fuel standards. They can have their own mini energy policy. And many of them have said their word. Whether that will translate into a national policy, there are a lot of debates. There are a lot of opponents. There are vested interests. We don't know yet. But I think that the question is, what is the alternative? So we can sort of walk through the alternatives and see that there aren't that many. One is biofuels. Biofuels in China is almost a non-starter. I mean, it's there in very small quantities, but the Chinese government has banned the use of food products for fuel manufacture. You cannot, unlike the United States, you cannot use grain to make a fuel because it affects the food supply. So that's not allowed at the moment. And even if it were, I don't think that it could scale up in a country like China. They may decide to import more, as they do, and they import more and more, but again, that's not very scalable. Natural gas, right now, it's not there because China doesn't have the infrastructure and doesn't have also, for example, in China, current rules don't allow production of methanol for transportation from natural gas. So you can manufacture methanol from natural gas, but it is directed to the industrial sector, not to transportation. So that's out of the question. What you can do with natural gas is natural gas vehicles. And as I said, China, despite the fact that natural gas is more expensive there than here, they're still way ahead of us in deployment. Electric vehicles, we said before, starting, but it's still very, very small numbers and a lot of bottlenecks. So when you really look at the alternatives, have I forgotten anything? Any other magic bullet?
Well, I thought hydrogen was for a while.
Hydrogen. Since George Bush left the White House and Arnold Schwarzenegger left Sacramento, that hydrogen is still made from natural gas, certainly. But it can be made also from coal, if you insist. But again, we're not there. So there aren't that many options here. So if you really are Chinese policymakers and you look at the policies that are available to diversify your fuel supply, methanol is pretty much your only game in town. And that's why I think that eventually when they weigh all the options, they will go in this direction. And then it will be interesting to see what happens to the automakers, because the automakers will look around and say, okay, this is where they're headed. We're going to have to satisfy this market. We're going to have to certify those cars. Interestingly enough, I was just in Israel last week, and Israel was selected by Fiat Chrysler, to do a pilot on methanol cars. Fiat, to those of you who don't know, one of the biggest successes was the Brazilian ethanol program. They were one of the first companies that recognized the potential for ethanol in Brazil. And they were the first to market with a car. And they're hoping to do the same, to be the first foreign manufacturer that comes with a fully certified methanol car for the Chinese market. Now, the Chinese automakers are there already. They're making those cars. In many cities today, all the taxis are methanol vehicles. And they're made by companies like Geely, for example, has taken over the taxi fleet for methanol cars. So they're mass producing it, and they already have a capacity to build 200,000 cars a year, methanol cars. So the question is, at what point the other ones, the international manufacturers, will pay attention? What point Volkswagen, which is a very popular brand in China, may decide that they want to clean up their act and come up with something new. I don't know, but what I can tell you is that they're all paying attention. They're all looking very carefully at what the Chinese government will decide to do. And if they see that the government is moving in this direction, within a very short period of time, the cars will be there, because it's really very simple to make those cars. Yossie's foundation could demonstrate it if you're interested. I'm sure that they have literature on this, but there's nothing difficult here. Not at the fuel side, not at the refueling side, not at the blending facilities. It's really, really low tech. And it's very cheap. I mean, it costs nothing to make those cars. Maybe a little bit of different materials in the fuel lines that are more resistant to corrosion, things like this. But it's not a big deal at all. So I think that the next year will be very critical. Why? Because the next year, this 2015 was the year of pilots, in which the Chinese Ministry of the MIT, the Industry, Information and Trade, introduced, I believe, 7 pilots, testing different criterias in each one of the cities. And by the end of this year, those pilots need to ramp up, and then the results will come in. What we've heard is that once the results come in, it'll be probably 6 months of review process. Sometimes in 2016, there needs to be determination on a national standard. So this is going to be a very important year for the methanol industry in China. And as I said, it could go either way. But it will be very interesting, and I think it will give a lot of support to the Chinese policymakers if they see that the United States is also interested in going in this direction. Now, we have a Secretary of Energy that in his previous position at MIT was the principal author of a report about the future of natural gas, and he gave 2 thumbs up to methanol, and in fact, I think the report concluded it's one of the best ways to utilize natural gas in transportation. And now he is in the position to implement it. Hasn't happened so far. But maybe after Iran and after Paris, there'll be time to give the thumbs up, because I think it will go a long way with the Chinese when they see that this is something that the United States is also considering.
Let me give you a little bit more of a background in what I see about ethanol in the U.S. And ethanol, as most of you know, you go to the pump and you're going to get some ethanol in almost any place you buy fuel in the U.S. at this point in time. I would argue that that decision was driven as much by agricultural policy as it was by anything else. There was a time when we were very concerned about liquid fuels and the ability to get fuels in the U.S. and looking for alternatives to petroleum. And the ethanol seemed like a good way to do that. If you look at what has happened in Brazil, they have certainly made a success story from homegrown industries using ethanol and building the vehicles to use them and integrate them very much into their infrastructure. In the U.S., we've done the same thing. We now have a virtual, it's almost impossible in most states in the United States to find fuel, gasoline, that does not contain ethanol. There are a few states that will allow you to sell it, some that will not. The government certainly doesn't like it. So the ethanol has certainly become part of the U.S. psyche. I think that much of that was driven by a way to try and provide some additional support for the agricultural sector and the corn sector in producing ethanol. There has been a tremendous amount of research done in the U.S. to find ways to provide cellulosic ethanol, to be able to cost effectively take wood byproducts, any other forms of ethanol, of cellulose, and make them into ethanol for fuel. Those programs, at least from a industrial perspective, have not yet come to fruition. And there is not a, there are a couple of cellulosic ethanol plants in the U.S. that are operating. I think they're relatively expensive, and the technology is still being developed. I know at our university we have several programs that are still looking at how to develop cost-effective ways to develop ethanol from cellulosic materials. So I think that's going to continue in the U.S. I don't see any particular push to change that in the near future. I think that depending on what happens over time, the food-fuel trade-off may become more important. In China, the food-fuel trade-off has gone the other way. Basically, you don't use food for fuel in China. And so we have a very much of a dichotomy in that between the two countries in terms of what we've done. And it really has to do with a natural resource base. It has to do with what makes sense in the countries. And somewhat it's historically driven by what drove those decisions in the first place. There was a time when we really worried a lot about getting petroleum for fuel in the U.S. and we're looking for alternatives. At this point in time, a couple of things have happened. One, right now, petroleum prices are pretty much down across the board. But for the first time in many, many years, the U.S. is potentially a net exporter of oil. And what we've seen in the U.S. is we have laws, as you know, that says we can't export it. Many of the issues that have been trying to push or to change those laws were not so much because we needed to be a net exporter of oil, but that the kind of oil that we have in the U.S. and that we're building out of the Balkans and out of the Bakken and other places do not match with our current industrial ability to refine them. Many of our refineries are built for heavy crudes. The Balkan is a very light, sweet crude. And so we've got this issue. We've got base material which we don't have the capacity to refine effectively. And we have refinery capacity which we don't have the ability to serve internally effectively. So we're almost forced into building or bringing in heavy crude from outside to fire or to keep the plants running in Texas and Louisiana in that part of the world. And at the same time, we've got a huge amount of oil coming out of North Dakota, much of which is going outside the U.S. or going through Canada, because we don't have the ability to refine that either. So one of the things that I think as an economist is that we build these barriers into the way we do business, which oftentimes are very difficult to change once they're in place, and yet make very little sense from an economics perspective. In terms of methanol as a fuel in the U.S. is not a major player in the game at this point in time. Much like ethanol is not a major player in China, where they have a major methanol component in their fuel supply. So I think it's interesting to look at the comparison between what we're doing in the countries. It's based much on our natural resource base and what we have, what's available, and what's cost effective to do. The other thing that's happening in China on the methanol side is huge increases in methanol usage, not just for fuel, but for methanol olefins, the MTO plants. I think there's somewhere around 20 MTO plants under development, or maybe more at this time in China, to take that and basically provide the background for much of the plastics industry and those things. So the U.S. plastics are almost all come from petroleum-based products. In China, they've traditionally come from coal-based products because China has lots of coal, and they also are very, very, very good at coal chemistry. The ability to deal with coal in China, I think, is something that the U.S. has worked on and has been at times, but we've never had the economic forces to drive us to provide the kinds of infrastructure in coal that they use in China. So we are, and it's going to be interesting to see what happens in the U.S. in the future, because we now have what I think is going to be a significant amount of stranded coal resources. We have a huge amount of coal in Wyoming and still a large amount in Appalachia and throughout the U.S., which I see under current things as we're probably not going to use in the power plants as we have been in the past. And one of the things that I think is going to drive the future decisions in all of these areas will be what comes out ultimately in international agreements on carbon management. Whether you can call it climate change, whatever drives that is one thing. But if we end up with things that drive the carbon intensity and the carbon emissions in a way that will drive market forces. Right now there's no price on carbon. Economists always ask for that because they said that would allow businesses to make decisions and go forward in planning in a way that would be reasonable. Right now these are driven by political processes. And I think that as we look at the U.S. and where we go with ethanol, and if you take a carbon footprint of ethanol as it comes in the U.S. and you take a look at that in terms of the way we produce it from corn, it's a slightly different picture than you get when you just look at ethanol per se. And so I think that one of the things that is important is to be able to step back, take a step back, and really look at not only the economics of the system, but also look at the carbon footprint of the system and where it comes from. And those are things that there's a number of research studies done at universities and throughout looking at various aspects of the system. But there's never been, I don't think there is yet, a coordinated, concentrated effort that actually provides all those trade-offs in a systematic way. And because there's not been any political reason to be able to have to answer that question. But I think it would be an interesting question to answer. There are certainly lots of pieces of it, and we know a great deal about trade-offs in many sectors, but the cross-sector comparisons are harder to make. And I perceive that we are in a transitional period around the world at this point in time in terms of what our transportation fuels are going to be. There's a lot of talk about electricity. I think electric cars are great, but it's going to take a long time to build, make the kind of investments it would take to make that or significantly change the transportation infrastructure. And in many of the developing countries, I think that's several steps back. I think that in this particular case, the U.S. and China may very well be in the lead, at least on the major economies, and we'll see where that goes. But you know, so what you see is the U.S. tends to be, at the present time, in terms of transportation, ethanol-based. China tends to be methanol-based. I don't see any forces that's going to change those in the near future. But, and I sometimes wonder what the net impact, at least in the U.S., is from using ethanol in our fuel supply, both economically. It certainly transfers money between sectors in our economy, but also in terms of ultimately the issues that we're going to face on carbon management and climate change and what goes on in the Paris and the following rounds. I don't perceive we're going to see a lot of answers coming out of Paris, but perhaps we will, or at least maybe we'll take a little baby step farther, closer to a solution in that area. So just a few comments.
Before I turn it over to questions, I promise I will not ask questions, so you'll have more, but instead I'll say something. So you know that I'm always about price, okay? I don't know if you noticed. But the numbers are that you should know today. So the cost of producing a gallon, I'll translate to American terms, okay, a gallon of methanol from coal in China is 50 cents or under, okay? 50 cents a gallon. The cost of production of methanol in the United States from natural gas today are also 50 cents. Cost of production, especially with cheap natural gas right now. If you even at $8 an MCF, it's 70 cents. Okay, so we're in a curve. The curve is mostly the capital. There's now new technologies. Now, speaking about other numbers, the world uses 93 to 94 million barrels a day these days. I mean, it's moving up about 1 million a year. Out of those million barrels a day, 2 million are ethanol, about 1 million from corn, about 1 million from sugarcane. So even if you assume that ethanol will double over the next 5 to 10 years, which it probably will, for various reasons we don't discuss right now, we're still actually looking at much farther growth because the world grows about 1 million a year. So we really need more liquids. Whether those liquids are oil or not, I doubt they'll be all oil. Okay, I don't think people talk about the glut. I don't see the glut. It's more propaganda than anything else. If you actually look at the numbers, numbers could be hitting some dire strait in very short time. I'm not saying a month, and I don't suggest to invest, but I'm talking short time in energy. A few years is a short time in energy. Okay, anything that you do today affects what will happen 10 years from now. And there is another technology to take natural gas now to and make ethanol from natural gas. And at $1 or $2 an MCF today, that is also about $1.10 a gallon. So we're talking about economic transition here that could happen because it is cheaper and we can transition $1 trillion of investment, okay, and use the gap of pricing between coal and oil or between natural gas and oil to a great degree to achieve a much cheaper transportation. And by the way, most importantly, which I'm not going to talk about the carbon. There's a lot of disagreement about whether that is carbon positive or not, although we think it is. The more interesting thing, and that's what Gal read, is both alcohol fuels are much better for the environment in terms of air pollution. So cutting down air pollution by, if you're talking about NOxes, it's 50%, a lot of other particulates, 50%. We're talking about major improvement to our air quality. And in China, I think, also. So ethanol, methanol are really the only way to go right now in air quality on the short term. That means the next 30 years before electric cars pick up some serious steam in terms of quantity. So I think this is kind of an interesting phenomenon. We have to look at the numbers. The numbers have changed from the old days of ethanol, which is still, by the way, produced at high profit today because it just became more efficient. So ethanol, U.S. ethanol 10 years ago need to be subsidized. It is not today. It is competitive today, even to cheap oil. It's very interesting, okay, what happened. And it's called American industrial innovation. You keep improving every year because you knew the subsidies would go away, and then you got better. We know how to do that probably better than most. So at this point, after throwing some numbers at you, I'll direct questions from the audience, please.
Thank you. Beyond the production and the use of ethanol by themselves, would you expand a little bit more on the trade of ethanol internationally, including the state of art in terms of some mechanisms that at least were used in the past, like triangulations between Central American, South American, and the U.S., or splash and dash mechanism that was used in Europe. But I'm not sure that included ethanol as well, or just biodiesel. If you could talk a little bit more about trade of ethanol internationally.
You're the. I'm just a moderator. Not innocent bystander.
The issue of trade is has to do with two things. One is the cost of transportation. So the further away you take it, the more you pay. And second is regulations and trade policies and trade treaties. So, for example, I don't know, suppose there's Trans-Pacific Partnership comes into effect. You could see, although China is not part of this, but you could see, and I don't know what would be the implications for ethanol trade, because I'm not sure that the economics work. It also depends on the competition with gasoline prices, what would be oil prices and all this. But what we do know for sure is two things. One is that surpluses are very cyclical. The bad years and good years, particularly in sugar. Right now, sugar prices are very, very low, extremely low. In fact, sugar prices have fallen far deeper than oil prices in the past 2 years, because there's excess capacity of sugar. More and more sugar is diverted, because sugar, I mean, there's a limit to how much chocolate you can eat, okay? So if
You said so.
so the transportation sector is the only place that can absorb the surpluses of the sugar, okay? But if you look 3 years ago, we had a sugar crisis. Prices were sky high. So we're talking about agricultural commodities, and they're very cyclical. And they're subjected to natural causes, subjected to disease. All kinds of things affect those prices. So right now, 2015, there's excess sugar, very, very low, I think 55 cents or something like this. And you could see a ramp up in surpluses will lead to more trade. But that's not something that you can sort of predict indefinitely. But in terms of China, I can tell you that they are increasing the imports of ethanol quite significantly. It's not big numbers in absolute terms, but in relative terms, it's. I think they doubled their import, and they are planning to double it again next year.
Yeah, Fu Qiang from NRDC. I have one comment and one question about the alternative fuel in China. For the coal-based, the methanol compared to the petroleum-based methanol, and why the China is use the coal, because at beginning the coal at oil price is higher than $100 per barrel. In that time, the coal-based, that is good, but now it's a drop. Now in China, the coal-based methanol now is stuck there, because now from economical sense, it doesn't make. So compared to the alternative is from the carbon footprint, it doesn't make sense. From others, for the methanol coal-based, one is things I would like to ask your question is water, because they use a lot of water. 1 ton of methanol, they use 12 to 15 tons of water. In China, water in that coal-based area, you cannot ship to otherwise it lost the economical sense. It doesn't make sense. And so you have to there. But in the most coal-based area, no water resources is abundant. You are available to do that. So second is coal-based methanol is quite difficult to clean up the water pollution. That is different from the petroleum-based methanol. So do you have any idea, say, water crisis and pollution, water pollution?
Well, I guess what I would say about that is it certainly is a big problem and it's well known. And in the latest round of the agreements between the U.S. and China on joint cooperation included another portion of the Clean Energy Research Center, which is joint between the U.S. and China, and that is on the energy-water nexus. And much of that deals with issues on the Chinese side of dealing with the shortage of water and the management of water in the coal areas, which clearly are semi-arid probably at the best. And water resources have been a major problem. When I first was involved in China was with some of their coal to liquids facilities, which also have that same issue where they're cleaning up the water. They have about the same kind of ratio of 10 plus to 1 of water to liquid fuels. And at the same time, they have some significant issues dealing with the environmental concerns that come from those processes. They're very, very complex for those that, and I'm not a chemical engineer, but talking to my chemical engineering friends, those processes are really some of the very difficult ones to deal with. And cleaning up the residues that come out of those is also major. So you have two issues. You have the environmental concerns that you talk about. You also have the issue that water is very, very short. And in the U.S., where we have most of our coal, it's pretty short as well. Wyoming is definitely not a coal or water excess area. So water resources and energy, and particularly in the coal water side, are going to continue to be a major concern. I don't think we have answers to those. Otherwise, we probably wouldn't have a new joint agreement between the U.S. and China to try and figure out how to do something with it.
Yeah, but you have to compare it to the alternatives. Okay, in Daking today, they inject so much water into the oil field to increase the reservoir pressure because they are declining, that I can bet that oil production in China is more water intensive than coal to methanol. Okay, so
Yes.
One thing. Second thing is shale gas, also intensive. Okay, water intensive, you agree? Okay, so we have, and certainly if you were to grow biofuels, that's also water intensive. So we are talking about alternatives, and we have to compare an alternative, not to compare to a hypothetical solution, but based on the resources that exist. This is the lesser of all evils, because if you drive an electric car made on nuclear energy, that also takes water. You have to. So every source of energy, I cannot think about any sources. Very few sources of energy that I could think of. I don't know that don't involve utilization of water in the end, because you talk about cooling stuff and methanol. Methanol requires some water, but it's still not the most water-intensive fuel from the menu of options that we have. So I don't think it's... and also you can import methanol. I mean, look, what's the difference between importing gasoline and importing methanol? If you have to import most of your fuel, why does it matter if you import gasoline that was made from crude in Saudi Arabia, or you import methanol that was made in natural gas in Oman? You import liquid. The question is the economics. Does it make sense that the replacement value is there or not? And I grant you that at $40 a barrel, it is a challenge. But any responsible policymakers need to look into the future and see that if and when price bounces back to where it was, consumers can switch on the fly from one fuel to another. The infrastructure is there, the cars are certified to run on the alternative, everything is there in place. Doesn't mean that you're going to use it every time. But you want to make sure that you have a system that is diverse enough and flexible enough so that you can move back and forth between different fuels as the economics change.
I want to mention a couple of more things. The most water-intensive crop of fuel you have today is oil, the way oil produced today. And of course, I don't consider rainfall. So, for example, if most of our corn is grown by rainfall, if you calculate rainfall in it, that may change. But it is not the same, okay, as taking real water, collecting him, injecting to the ground, and other stuff like that. The second thing is about greenhouse gases. The latest data that we have, and it is the latest data, is the following: coal to methanol is negative on the greenhouse impact. Natural gas to methanol is positive. It's not positive by 50% or something like that, but it is positive by something, 5 to 25 at least, and I'm conservative. And the reason this is so important is because nobody in their calculation of coal is doing the time impact. So people rather get 60 something that is 80% less carbon in 2035. While we know today that if we save 10% or 10% a year, starting from today, the impact on the climate on the overall time is actually net present value is bigger. But it sounds like we're only saving 10%, but we're starting now. So I have to be very, very careful when you measure, because timing also affects the result. Do we have solutions that are completely clean, no water, no problem to clean them up, no carbon? Yes, in theory, we will have maybe a fusion in 30 years. Although there is a company in California that made a significant breakthrough on fusion, where I think we can finally say that fusion is not always 20 years away. Now it's 20 years away.
I'm going to ask you to take a more speculative question. I'm struck by the idea that what we see in the case of China in terms of, let's just stipulate that that non-petroleum liquid fuels market will be dominated by either ethanol or methanol. I'm struck by the fact that in the case of China, obviously the technological momentum points towards methanol, whereas in the United States, the technological momentum points in the direction of ethanol. And I'm also struck by the thought that when you think about China and its coal resources converting to methanol, you think about India and its coal resources, you think about Indonesia and its coal resources, you can almost sort of see the formation of a sort of methanol block here, you know, extending across into South Asia and into Southeast Asia. U.S. natural gas converting to ethanol. I'm looking down the road a bit. My question is it possible to, how difficult would it be when thinking about it in terms of infrastructure, right, supplying non-petroleum liquid fuels derived from either coal or natural gas, how difficult is it to develop, in a sense, a kind of ambidextrous system in which you're able to shift from methanol fuels to ethanol fuels and be able to basically do it without your car conking out because it's geared towards ethanol versus methanol? Or is there possibly a really, could it be the decision to opt for methanol based, for methanol as a alternate fuel versus ethanol? Could there be momentous economic consequences down the road by choosing one or the other?
Okay, forget about ethanol and methanol. Alcohol, okay? They're both alcohol. If the car is certified to run on methanol, which is a more corrosive of the two, it can also accommodate ethanol. So it's not one or the other. You could blend all three. It's okay. But the car needs to be certified for it. And if needed, retrofitted. But the three liquids can coexist in the same fuel tank. So that's the most important issue now is certification. By the way, in China, for example, there is a fairly developed industry of retrofits. Not so much today because, again, the price differential is not sufficient to encourage this, but in the good old days of $100 oil, a lot of people did it. And we saw that there were qualitative difference between the kits. Some of them were really bad, and they were cheaper on the upfront, but then you'd pay higher cost in terms of replacement of filters and so forth. But they would range from 500 yuan to 3,000 yuan. Okay, that would probably the range of the retrofit kit. So that happened a lot. Why? Because people want to capture the saving. And if you're a taxi driver, for example, you could make $3,000, $5,000 a year just on this kit. Each country will have its own calculations. It's not a technical issue. It's really, from a technical perspective, we're not talking about adding a new powertrain. We're not adding another engine or, it's really a low-tech challenge. It's more of a certification, regulation type of thing. It can be done. It should be done. It's a no-brainer. Whether the fuel will follow or not, that will depend on many factors that nobody can control. But if you believe that sooner or later oil prices will bounce back to the 3-digit level price, then it makes a great deal of sense to prepare the car or to make sure that cars, because when you put a car on the road, it'll be on the road for 15 years, okay? So anybody in this room thinks that in the next 15 years the price will remain under $80 a barrel? It's very unlikely. So if we think that in the next 15 years the price of oil will bounce to the high-level price we saw before, then why not make cars that have the capability? Now, I want to say another thing. We talked about fuel efficiency here. What happened with fuel efficiency in the United States? Okay, in the United States, the Obama administration passed new fuel efficiency standards. When was it? 2011? 2011, I think. 54.5 miles per gallon. Okay. 54.5 miles a gallon. Where are we today? Anybody knows? We're 25. In fact, fuel efficiency are going down, not up. We're 25. We're halfway, less than halfway. So now you ask yourself, if you are the auto manufacturer, how do you get to comply with fuel efficiency standards that are double in just 10 years, because they're supposed to do it by 2025, 10 years from now? One of the recommendations that we have here is to make the task easier for the automakers to reach the stated goal, the target, by giving them credit if they make cars capable of running on alcohol fuels. So suppose if you are a manufacturer and you make 50% of your fleet flexible fuel, you get, 4 or 5 miles towards reaching the stated goal of 54, which you're not going to get anyway. Anybody thinks that we can get? It's almost, I think it's an impossible task to get there. But the administration is sticking to its stated goal. Maybe they believe that it's doable. Maybe the 54.5 mpg was enacted with the thinking that there'll be mass adoption of electric vehicles, which never panned out. Because, to remind you, we were supposed, according to the Obama administration's pledge, by 2015 to have 1 million electric vehicles on the road in the United States. Now we are at the end of 2015. We have 1 million electric vehicles on the roads globally. So, but not in the United States. So the projections were overly optimistic. But be it where it may, we have now 54.5 miles per gallon requirement. And I don't know how anybody can reach this requirement unless you give them some incentive, unless you offer them fuel choice credit to get a little bit further. So I think this is a way to advance this kind of vision by giving them incentive to meet the requirement that is in the books. And it's not a mandate. They can decide not to do it, but it's an incentive. So I think that's something that both China and the United States can agree on, for example, because after all, it's the same automakers that sell the cars in China and the United States.
I want to add something because it is a very important thing. We're looking at statics, but the world is not static. We have a target. The car manufacturers already filed documents with the Department of Energy and others, the EPA, that they cannot meet the 54 miles unless they raise the level of alcohol, which means raising the octane of the fuel, so they can raise compression. This is already, it's kind of, that's the common notion in the car industry. Of course, it's not accepted necessarily by the EPA, but I think it's also, from talking to our own engineers, this is probably correct, very correct, unless you are willing to invest $5,000, $10,000 more per car, and that is not something we can afford. Nobody can do on the same cars. So there's a study that has been done by MIT that shows that since all cars today, they are flex fuel, they are tuned to run on gasoline, but they can also run on alcohol. But if we decided to make cars that run on alcohol, optimized to alcohol, and also run on gasoline, but so-so, we can double the mileage. With current technologies, no new technologies, all exist already in the racing industry. Now, if we do that on a methanol car, and we double the utilization of methanol, then we're carbon positive. So that's another thing. We're looking at a static world in today's car, but we can open the door for a solution. And I want to remind everybody that when we got the first cell phones, they didn't look like this. Okay? So we opened the market for innovation for alcohol fuels and other fuels and flex fuels and computerized driving, and all of them together, we're going to get the results we want with almost any fuel. But definitely from a clean air perspective and mileage, we need more alcohol in the fuel in liquid technologies. Electric is the next big thing. Are we done, or any more questions? Thank you.